This is electrical systems 1, test 2. Electrical 1, test 2. You got that? Everybody got that? The amount of lead and acid in a battery determines the amount of energy or current the battery can store. Is that true or is that false? The amount of lead and acid in a battery, basically a bigger battery is going to store more, right? You got more lead and more acid in there, you're going to store more. Automotive batteries have 8 cells connected in series. How many you got? You got 6. How many cells are there in a 9-volt transistor battery? 6. Each one's 1.5. Got that? Alright, so you got cell. A discharged battery will not freeze. Number 3, a discharged battery will not freeze. That is false. A discharged battery will freeze. Yeah, and out in the cold weather, the water in the battery, you know, the electrolyte. I say water, the water and acid, you know. But number 4, as a battery gets colder, less current output is available. That's true. You know how on your battery you'll see that it's rated at 0 and at 32 degrees? You ever notice that? They got ratings on there, 0 and 32 degrees. Okay, so specific gravity compares the density of any liquid to the density of an equal amount of water. Is that right?
That's true.
That is true. Because the cells in a battery are separated from each other, it's necessary to perform the hydrometer test on each cell. If you're using a hydrometer, you know the thing you squeeze the little ball and the balls float? You'd seen them before? That's a hydrometer test. But you can also use that little refractometer for that. And all that. So you're going to have to check each cell. And right here, this right here will startle somebody if they don't know it's an empty shell. See the cells? Yeah, that's the cells in there. Now there's nothing in these cells. All of the lead and stuff is not in there. And so that's how they're totally separated from each other. You see, even all the way to the top, and you see these little right here. Those go all the way down, so there's not any transfer of anything from one cell to the next, except through the connection that the cells have, which are put together in series, starting with a negative terminal and going to the positive terminal right there. That's pretty cool. Right there. I got that Toyota battery. All right. Okay. Some vehicles have convenient connection points under the hood and away from the battery for jump starting. Some vehicles have convenient connection points under the hood and away from the battery for jump starting.
Yeah.
We got one out here. Which one? GMC's like that. Yeah, you don't even hook it directly to the battery. That's good too, because those side post GM batteries are kind of crappy. They do make some little copper things you can pop onto those. It makes it easier to hook jumper cables to, but they're not like great either. But, boy, they have hung on to them side post batteries tooth and nail for years and years and years. But of course, you are less likely to have a short with a side post battery. But I will tell you this, and this is words to the wise: a side post battery you won't see any corrosion a lot of the time. I mean, it looks just fine, but when you take the battery cable loose, it's just a chalky mess. You know, and sometimes I'll take that. You know that little Midtronics tester you hook up, it tells you how many cold cranking amps it's got? Did you see that thing? You can hook that up to those side post terminals without taking the battery loose and measure the cold cranking amps on that battery through using those, because you're really supposed to hook that thing directly to the post on the battery, not to the terminals. However, it's a useful tool if you hook it to the terminals and you measure the cold cranking amps and they measure really bad. Then what you need to do is pull your battery tables off, clean them posts, and measure it right there at the battery, and you'll probably find out. I have seen it where it would measure like 175 cold cranking amps at those posts or at the screws that go into the battery, and you take all those out of there and measure it directly coming out of the battery, and it'll be like 600. So you got a lot of corrosion and resistance there. See? And sometimes battery terminals can be dirty and not even look it. You don't always see chalky stuff. Sometimes it just won't. There'll be enough oxidation in between the post and the terminal where it won't flow. And I'll tell you something else. I've seen cars just plumb quit running and going down the road because of dirty battery terminals. You'd swear there's something else wrong with them. I mean, when in doubt, guys, clean the battery terminals. Just you know, and don't let any. It's not a good idea to let anybody's car out of your service bay with crappy-looking battery terminals. And it's a whole lot better. It's better to do that for free than it is to let them go with crappy battery terminals. Because if it goes, like if you did a service on a car and you're supposed to check everything, and they get down the road at a gas station, and for whatever reason, maybe you disturbed some stuff and didn't clean your battery terminals. Well, I just had this thing worked on at the dealership. I wonder why in the world it won't start now. It has to be something. So somebody's got to pay for a wrecker to get the car brought back up there, and so on and so forth. It makes you look bad. That's a strange thing. How sometimes too, when you go out there to get in a car to crank a car that's been cranking just fine, and hadn't been any problem at all with the battery, you go out there and go to crank it, and won't crank, and it'll be boiling one of the cells. Just boiling a cell, just boiling to beat the man. Stinking, if you smell it stinking, you know, rotten egg smell, that's when you need to keep sparks and cigarettes and stuff away from it because it'll blow up in your face. Seen them do it. One time, me and my boys were over there at, close to, we were in Savannah, and we were down there at Richmond Hill at a little place where you go down there, sort of like a community center where you just play basketball and stuff like that. And it was just getting dark. Anyway, I was driving a little Nissan Sentra. I got in that car. When I started it up, the battery, boom, blew up like dynamite right there under the hood. And so all of a sudden, you used to have a battery, now you don't have one.
What causes the battery to short?
Well, what happens is that the little connections in there start to get weak, and it actually, you may even have a bad cell, and so you all got all this explosive gas in that battery, you know, and that little, you know how sometimes have you ever seen under the hood of a car when you go to start and the battery terminal spark a little bit? That happens inside the battery, and you got an explosion. That don't happen very often, but I'm telling you, if you've ever had a battery blow up on you, well, you will not forget it.
I've had it on.
You know what I mean?
I think I have.
It's about this close to being shot at by somebody, but you don't. It's not malignant intent. The battery just blows up randomly. You know what I'm saying?
Just looking up a positive wire, and I ran it through underneath my body, and that happened to the outlet.
Yeah.
And a little hole, the ground hole.
Yeah.
And they grounded it inside and blew the caps off the battery.
Yeah. That was
Put that grounded wire.
Yeah, tape them up, make it look really good, plug it in, make sure the fan works good, and do all of his, check his fluids and his tire pressures and everything. We'll be good to go on him. Okay. Okay, automotive batteries are called what? What are they called? Are they called primary cells, secondary cells, charging cells, or live cells? Anybody got any idea about that? That's actually a B there, the secondary cells. Slow charging of a battery uses a current of, what do you think?
C.
You say C? Number 9 C sounds like a good answer to me. What about you, Sean? You think you like it? Pretty good?
Yeah, that sounds pretty good.
Yeah. Routine battery maintenance does not include what? Huh? What do you think? Look at the three. Look at the answers. Somebody, huh?
D.
D. Yeah, he's a smart guy. You're not going to reverse your terminal connections, because if you do, you cook things. Eddie's wife, when he was gone overseas, he was over with the Coast Guard for a while. She was at a local filling station or something. I don't know where she was when he had it done. And they were looking at putting a battery in it or changing an alternator or something. And somehow or another, they set the battery in that box backwards and they hooked the battery terminals up backwards on it. And so whenever they got done, her gas gauge didn't work. Her variable assist power steering was stiff all the time. It was hard to steer the car. And I don't remember what the other details were. I wrote a Motor Age article about it. It fried the fuel tank, the fuel gauge slosh module, which is the module that keeps it from gauge from moving too fast. And it fried the body computer, the little gem module on that car, destroyed that. That's why the variable power steering wouldn't work. And it seems to me like, if I'm not mistaken, there was one other thing that it destroyed.
Why does it do that?
Huh? Well, you got all kinds of little circuits and diodes and everything that the current's supposed to go only one way through that stuff, and when you hook it up backwards, it cooks little circuit boards and destroys stuff and just poof, lets the smoke out of things, burns up transistors, you know, because they're set up for current to flow one particular way. If you hook it up backwards, it goes places it never was supposed to go, and it's sort of like, you know, punching it in the teeth with a real, you know, knocking half of its teeth out. So a battery load test or high rate discharge test measures terminal voltage while the battery is supplying current for 15 seconds. All right, how many of you know that if you put a battery on high charge, like you put it on fast charge, and you leave it on fast charge for 3 minutes, and you check the battery voltage, this is very easy to do. Hook your battery charger up, one of them big ones like we got here. Fire that thing up on high charge and let it charge on high for 3 minutes. And when you put that meter on that thing, after it's been charged for 3 minutes, if it's above 15.6, the battery's got sulfur coating the plates and it needs to be replaced. That's a go, no go test. If you see it go over 15.5 volts, and I've seen them go up 17, 18 volts, if it's taking that much push to shove that charge in that battery, it's going to pass some crud on the plates. And that's called a sulfated battery. S-U-L-P-H-A-T-E-D, sulfated. If the battery's sulfated, if it's taking that much current, put a battery in it. Not supposed to go that high.
Boy, so you're talking about the 24 volt, some kind of 24 volt jump or something on a
No, I'm just talking about if you hook your battery charger up to a battery that's sitting on a bench or wherever you got it sitting, you just hook it up to charge it. I mean, like it's, you know, the terminals are clean. I'm going to clean the battery up. Now I'm going to put a good strong charge on it. Hook that battery charger up, turn it on high charge, wait 3 minutes. Use your voltmeter, just like one of these little voltmeters over here. You know, while it's charging, just stick your voltmeters positive to negative and read what that meter says. If it's more than 15.5 volts, that battery is sulfated. Now it may start in the car, but it ain't going to be as strong as it's supposed to be. And you know, it's going to be, and that was something that's a standard thing that anybody that teaches about batteries is going to teach you that, but it's something a lot of people don't ever check.
What is it supposed to be?
Well, they never supposed to go over about, well, it's not supposed to go over 15.5. Closer it gets to that threshold, the more of a problem you got. Usually it'll be 14, 14.5, something like that.
Is that why you have to replace them every now and then? Is because they just...
Well, batteries like run out of gas. I mean, they just, some of them last longer than others. But if you look at a cold cranking amps on a battery that you put in a car, like right now, and you're going to see, like, if it's supposed to have 850 cold cranking amps, it's going to have 850 or 900. Well, you drive that car for 5 years normally, you know, just driving it for 4, 5, 6 years, even keeping your battery terminal clean, all that kind of stuff. Every time you check that thing, like if you checked it once a year, it's going to lose a few cold cranking amps every year. And finally, by the time 5, 6 years has gone by, you may check an 850 cold cranking amp battery and see the cold cranking amps down around 250 or 300. It just slowly runs out of cold cranking.
Brake fluid and tire steering fluid.
Now there's some, find some out there. There ought to be some already poured out. I think there's a big jug of power steering fluid on one of them benches. But, all right, so, but remember that, what I was telling you, if you'll check that thing, it's an easy test, and it's a go, no-go test. That's one of the tests that I like about, if I've got a test that I can check really easy, and it can either pass or fail something, you know, now there's some tests that you can do, like there's an alternator, a test I can show you on an alternator with a meter, and I'm going to show that to you this semester pretty quick. If you just go from you get a meter that's got diode test on it, and you hook it, you know, you got your big post on the back of your alternator, and you get that meter, and you put it on diode test, and you hook it from the big post to the housing on the alternator, and you ought to read something up here, you know, one way but not the other way, like you're going to read a number of 500 or 600 or whatever. If it doesn't read either way, the alternator is bad. If it reads the same both ways, the alternator is bad. However, if it reads good, like 500, 600 on that number on that meter one way, but nothing the other way, that doesn't mean the alternator's good. It could have other problems you gotten checked for. But it kills the alternator. It's a killer. I mean, it's a kiss of death if you measure it both ways and it either reads the same both ways or it don't read it all both ways. See what I'm saying? So there are some tests that will, if it fails the test, the alternator's junk. It can pass that test and the alternator still be junk if there's something else wrong with it that this test doesn't check. Like I can have in that rotor that spins in the middle of the alternator, it's supposed to have 3 or 4 ohms of resistance right there where the brushes, operate. All right, if it's got 3 or 4 ohms of resistance, then that rotor, basically, the winding in the rotor is good, but it could still be shorted to the housing. The rotor, that winding's not supposed to be shorted to that clamshell metal housing. Then all of that stuff, anything you can check on that rotor is not going to be measured this way. That rotor is totally unchecked. You hadn't checked anything on that rotor when you do this. You're just checking the rectifier bridge and the stator is what you're checking that way. All right. But anyway, it's like I say, you got to be able to parse that so that you'll know just because it passed this test, it doesn't mean the alternator's good. So don't get confused by that. An open circuit test or at rest voltage of faulty charged battery is what? Sorry about that. Which of the following is not a color used in built-in hydrometers? Which one, number 12? That's going to be C. You don't use white. Not a built-in hydrometer. You know what a built-in hydrometer is? Have you seen on some of them batteries, they got a little sight glass on top of the battery that's supposed to change colors when the battery's charged up, like on some of the alcohol batteries? It's got a little ball in there, and if that ball, see that ball's sitting in a little, you haven't seen that? It's a little round plastic window on top of the battery that you're supposed to look down in there, and if it's green, you'll have a little thing like this, and you'll have a little optic fiber going up there to this little window on top of your battery. And if the specific gravity of that battery gets low, that ball will sink and go down one way or another. And when you look down in there, this will be black. But if that ball's up here at the top, because of the specific gravity like it ought to be, you'll look down there, this will be green. Now occasionally they'll have one where there'll be a red one will come up and a green one will go down, but I've never seen that many times. So white's one they don't use. An open circuit or at rest voltage of a fully charged battery should be what? That's A, 12.6. You know what the specific gravity of a good cell would be? The 1.260? I mean, isn't that something that 12.6 and 1. That's fairly easy to remember because they sound similar. All right, is that all your questions? Huh? That it? Yeah, is that all your questions? You got your electrical test 2 over there?
I don't have my electrical test 2 in here.
You don't have it? Huh?
I finished on my worksheets for this.
You got your electrical test 2?
Do it, yeah.
Okay. All right.
I still don't forget. I better turn it in.
You already done it?
I could have. Well, no, I haven't done this.
All right.
What you want me to do?
So, could you,
That's your syllabus. You hang on to that. This is plugged into house current right here. You got that? All right. Now, my little picoscope here is actually measuring on A. I'm going to turn off A, and I'm going to put this on auto. That's D. Well, it might show up there if I use it. Let me go ahead and put that back in place. Let's go ahead with A. All right. Here's my A probe right here. And that scope is pretty doggone sensitive. See, it is moving it around and touching it with my hand is making me do all kinds of crazy stuff. All right, now you see what we got here? I'm going to show you this to start with. All right, coming out of here. Watch this. This is, you were talking about a transformer. We got 120 volt house current coming in here. This I got from Radio Shack for $5. This is a transformer. Coming out of here, house current coming in here, coming out of here, I just got a small amount of voltage. All right, my test light is burning very dimly. Right there. See that? Right there like that. All right, if I go this way, I'm getting a full 12 volts. All right, so if this light's burning with that 12 volts, I ought to be able to make that motor run with that same 12 volts, right? That makes sense. Okay, so let me take that. I'm going to hook that up. And I'm going to hook it up to one of the terminals on that motor. And I'm going to hook that up to the other side so I'll get a full 12 volts. And I'm going to hook that up to the other terminal on that motor. I'm going to watch the motor real close. Real close. Now, it's hard to see it, but you see that's just sort of flopping back and forth. Alright, now if this is 12 volts, why is that motor not running? Why is it just buzzing? That's a 12 volt motor. Okay, this is alternating current, like what comes out of your alternator on your car. This right here is alternating 12 volt current coming out. In order to make this alternating current DC current, what we're going to need to do is we're going to have to run it through a rectifier. A rectifier, this particular little rectifier here came from Radio Shack, and it actually is like 4 little diodes. Okay, so I'm going to take it right there, connect that to there. I'm going to get a green wire for ground. I don't know why, but my black jumper wires always seem to go away. I can buy a pack of jumper wires, the first ones get burned up or destroyed or something with the black ones. Alright, now we're going to hook this up to this motor right here. We rectified that current and turned it into DC current. Now what does that look like on a scope? Alright, I'm going to take my scope here, if this thing will cooperate with me, and I'm going to hook it up to there and there. Alright, it's auto ranging. Just let it find itself. That's alternating current. You see that? You see alternating current, right? Okay, now that is not a lot of voltage. Look at this, it's actually going back and forth. My goodness, it's like 20 volts worth according to this. All right, what if I wanted all of that current to be above the zero? That would make it direct current, right? You understand the difference between direct and alternating current? Okay, let me take this right here. Now, and I'm going to hook it up here. I'm going to hook it up so that it's coming out of the direct current side of this rectifier. My goodness, now it's all above the zero. You got that? See what that rectifier did? Instead of having it reverse in polarity 160 times a second, and you have that. Now, what if I wanted this not to be moving around? If I wanted it to be still, the oscilloscope function is called trigger. Okay, so I'm going to put an auto trigger up there. Now it kind of sits still, right? What if I wanted a flat line? What if I didn't want those bumps? You know, because sometimes when you're doing sensitive electronic stuff, you don't want a ripple. That's why sometimes when you hook your battery charger up and you're trying to check things, your scan tool will go crazy if the battery charger's hooked up because it's got a ripple. This right here's a capacitor. It's the item right here. It's a capacitor, and you might also notice it's got a little negative, you know, minuses pointing to that side, so it's got a positive and negative, right? All right, so if I hook that capacitor up so that negative is going to the negative side, and touch both of them together, see? We've now got a nice flat line of 12 volts. We got a 12 volt flat line. Got that? You understand that? When I take that capacitor out of the circuit, now we got the bumps again. Now you understand why I'm telling you all this. The difference between alternating and direct current. This is a very short lesson. Don't take a long time. I don't have to spend a lot of time on this. But I mean, you can tell when you got direct current, it's going to fire up that motor and spin it. But your alternating current, the motor just going back and forth. Yeah. George, bring me that motor out of the vise. You know what I mean? You already done this?
Yes, sir.
Okay, you're good on that. We'll make that happen. Turn that one down. And bring me that motor out of the vise. You remember that motor I was playing with this morning? Yeah, bring me that. We'll show you guys something else that's really cool that I discovered this morning. And if George will hold this motor, I'll go ahead and get things really exciting. You can watch something happen that's really cool. Now are you guys understanding the scope thing now, right? You got the scope thing? You understand what it's doing? It's drawing a voltage over time picture. Alright, I'm going to take that off. Alright. Now then, we've still got power here. I wonder if we got enough power. George, we got enough power here to do this, you think?
Yeah.
And I just unhooked this and I shouldn't have. Alright. Let's point that camera down at our board. Let's point our camera down at our board. Like that right there. Okay, now we're coming off of our rectifier. It's still plugged into power AC in. We're bringing AC in. Now give me a big red and a big green, George. Give me separate them for me. Separate them to me a red and a green. Okay. Now where do the little brushes go? This is a little fan motor. This little fan motor actually came out of behind the car, you know what I'm saying? And I had somebody take it apart. And you notice this little thing will actually spin in there without any resistance much. This is permanent magnets around the outside of this motor. Okay, so if I take my red and my black. Now this may not have enough current. This little transformer may not put out enough current to do this. George, can you hold that motor? Hold it so we can see it right there. Hold it right there. George, are you scared?
No.
No. George is not scared. George has got nerves of steel. These are brushes, like you see in the motor. They were wore out, and that's why the motor quit running. See? See that? When I touch that, it's actually causing that little thing to spin. I really need more power. George, bring me a jumper box.
You have to physically touch it or just...
You gotta touch them. You gotta touch them. When those brushes touch these little commutators, it causes a magnetic field to run. Now, I knew that this little thing right here, it was not going to put out all much power. It did run the motor slow, and it made it easier to watch. All right, so let me get a red one. Let's take our red one and our black one. All right, George, we got to hold it where the camera can see it. Okay, can you hold it where the camera see it? Okay, well, we're the red one and the black one. Now watch this. Watch what happens when I touch these two brushes to that darn thing. See there? And all I can touch them. See? It's interesting how that works, isn't it? Now, what if I touched them somewhere besides right across from each other? What would happen then?
Maybe it wouldn't be as balanced or something.
I mean, it's still working. Now, the speed's going to be different. Those little suckers get hot because of the friction. But see, they're made out of sintered brass. That's the actual brushes out of the motor when it was in the car, and they wore out to where they wouldn't touch anymore. And that's why that's usually why motors like that quit. See, what the shame about it is, there's really nothing wrong with this little commutator. There's nothing wrong with these windings. There's nothing wrong with the bearings, but the brushes wear out. But there's no good way to replace the brushes, so you just go ahead and replace that. Now, a starter, a lot of times, if you can get brushes for it, you can fix a starter for $15 instead of having to pay $200 for another starter. See, and my dad did that whenever the starter was at tempo. Anyway, anybody learned something here that you didn't know when you came in here? All right, there you go. This is a live wire program that I bought a long time ago, and it cost about $600 for 10 years. All right, now the first thing I'm going to do with this is I'm going to put a battery out here, and I'm going to change the properties of it so that it's 12 volts. All right, this won't take very long, so just bear with me. Since we're going to ground everything to the rail on the car, I'm just going to put that down. I think I need to zoom in a little bit so we can make it bigger. Zoom. 200%. Now I got to go find my doggone battery. There it is. Can you see that? All right, let's zoom a little more, since we're doing it on our board here. Okay, view, zoom, 400%. How big does that make my battery? There it is. All right, now then, I got a battery. All right, now I'm gonna put another ground out there and just let it float in space. Got that? That's the ground. Okay, now we can also, you can also get a cell that's only 1.5 volts. But this battery right here, if we go output components, let's find the relays. There's a relay. Single pole, double pole relay. See that relay? Is that something you can see? All right, now I'm going to take that relay, I'm going to hook it up right there. All right, now then, I need a switch and an input component. Now I'm going to tell you guys, this is on most of these computers. And all you have to do if you want to play with this is fire it up and start dragging stuff out there. Okay, if you look at power supplies now, if you want to, you can get a fuse. And basically, if you're going to do this right, you probably ought to put a fuse in the circuit. And you can change the properties of that fuse to 10 amps. Okay, so, but it doesn't necessarily have to be 10 amps. It can be 1 amp. All right, now watch this. I'm going to come down here to that. All right, now I'm going to hit my play button. Now watch what happens when I turn that switch on. See what that relay's doing? You understand that, Daniel? All right. Now the terminals that you see on these relays, these two terminals right here that you see on this relay, the two that are side by side, that's the coil, that's the common. Okay, right here, look. Coil, coil, common. You understand that?
And then one of those other two that the switch opens to is normally open or normally closed.
Exactly. That one right there is normally closed, that one's normally open. This is the one that gets power from here when you energize that, or gets whatever you're feeding into that other one. Okay, let's move on. I'm going to take additional power, and I got to push stop before I can draw anymore. And you see a lot of relays that are wired up this way. See that? Now the key to this thing is that switch is very small. Right now I want an output component. I want an output component, which is going to be, you can put a lamp or a motor or whatever. For our purposes, we're going to put a DC motor there. You got that? We're going to put a DC motor. All right. And we also need a ground for our motor. See, I'm kind of cramming all that stuff in here really tight. I got to move my little my little pane off to the side here. All right, let me move that ground over here. When I put that ground right there, it'll stick. All right, now let go and click again. It'll let you change directions, don't you see? There, see how that works? Now watch me turn it on again. You understand what you're seeing? I'm trying to get you to burn this stuff in. Everybody needs to understand this. We're an electrical class for a reason. You got it?
So why, if we've got a switch, it seems like the relay and the switch are doing about the same thing.
They are, but the point is, all right, let's imagine you're in a situation where you're wanting to control a circuit that's really, it takes heavy wires and do it with a small switch. Like the ignition switch on your car, the battery cable that leaves your battery doesn't come into your ignition switch and then go down to the starter, does it? That'd be stupid, wouldn't it? You want to run a cable as thick as your finger all the way in the dash to the ignition switch so that when you do this, it's going to go to the starter. But what they're going to do is you're going to take a relay out there, and it's actually going to go down there and feed that little wire on the starter that energizes the starter. And when you turn your key, you may have a little bitty wire going out of the dash, and when it clicks that relay does all the work. See, the relay is supposed to be pulling in heavy loads. And your little switch that operates, it can be a little teeny tiny switch no bigger than that one right there. A switch that wouldn't handle the load. You know, you want a really small, weak switch to be able to cause something big to happen on the other end. A relay is the way to do it. Or, furthermore, if you want to back in 99, no, excuse me, 96, I guess it was. There was somebody, and this is an electrical thing, that's why I'm telling this story. There was somebody that had a Jeep, that was one, a Jeep, I'm sorry, it was an Explorer, and they drove it to Tennessee at night with the lights on, and it burned up the headlight switch. Because the headlight switch was really not engineered to handle pulling, you know, the 10 amps of headlight bulbs all night long. I mean, it got hot and it burned up, and their headlights went away, and they had to come back in the daytime without any headlights. Okay, so they gave me that job, and what I did was, I took the headlight switch, got a new connector for it, and I got in those days we could get a fuel pump relay with a pigtail to go with it, you know, because fuel pump relays sometimes would burn up and all that. And I mounted that fuel pump relay in behind that headlight switch, and I took the wires that were actually going, you know, you had power coming into the switch and then power going out through the dimmer switch to the headlights. And I took that power wire and I hooked it to the common terminal on that relay. And then on the normally open wire on the relay, I connected it to the headlights. You got it? So this right here was going to turn my headlights on. The headlight switch that burned up after it ran all night long, whatever, I connected it so that all it was doing was turning on that relay. And I soldered it up in there, and it was a Ford relay and a Ford connector, and I soldered a heat shrink, and it looked really professional. I mean, it was really great, and it worked great. But
now, on the reverse side, if you burn up a relay, does it leave the switch vulnerable, or does it cut it off?
No, the relay, what you got is you have two discrete circuits. Discrete, D-I-S-C-R-E-T-E. Discrete meaning separate circuits. So if the relay, now I will tell you there is a time when if the relay burns up to the point to where it melts everything together, you know, it can actually cause issues. I had a Crown Victoria out here one day that the fan relay was controlled by the engine controller. And I can show you pictures of it. And the fan relay burned up, and it actually made an internal short in the relay that was back feeding the engine controller. So there was enough of a voltage drop there that when the engine controller tried to kick the fuel pump on, the voltage would drop down so that this situation was acting like a turn signal flasher. The engine controller was going click, 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 because the fan relay had burned up and it was back feeding in there. So what you're saying, yeah, it can, but that doesn't usually happen. Now the relay is usually made to carry a lot more amps than that, and usually relays don't burn up. Now I think it was you I was telling yesterday about this 88 Ranger, because he was asking me about amps and everything, and I told him about this 88 Ranger that this lady had, or this guy had, that he brought it up there, and he says, I bought it, it came to us from AutoZone, and he said, I bought a alternator from AutoZone, and when I put the alternator on, it burned up the wires under the dash. And I want them, you know, and they said, AutoZone says, take it to the Ford place. If our alternator burned it up, we'll pay for whatever the repairs are. And so when I got his old alternator first from him, and I put it on there, it was noisy and stinking and smoking and hot, and it wasn't working worth a flip. Took it off, put the other alternator on. And you check the charging system with a charging system tester, what do you usually see? I mean, voltage. What kind of voltage you're going to see when your charging system's working?
12.6.
Well, not when your charging system is working. That's a fully charged open circuit battery. Charging system, what, 14 and a half? You've done that worksheet, remember? If you just look a voltmeter to a charging system was working, this one was showing 12 and a half, which is low. I mean, a couple of volts lower than it should have been. And so, this was funny because I put the alternator on there, and all of a sudden I see smoke from under the dash, just like that guy did. And I look down here at the inertia switch. You know where the inertia switch is on the Ranger? All right, it had burned. The inertia switch was burned up, and the wire coming to it was smoking and hot and all that. So, well, there must be some, you know, something going on there. That's where he saw his smoke at. And so my problem was deeper. This is an important story from an electrical standpoint. So listen to what I'm telling you. I fixed the inertia switch, new connector, new wires, soldered heat shrink, tightened up that link in the chain, right? Made it nice and fresh and looked like it was new again and all this kind of stuff. Cranked it up again. See what happened. I was sitting in the truck, and all of a sudden I noticed a commotion going on under the hood. And out there on the right side, back here close to the hood hinge, the relays out there were on fire. Literally flames this high out there underneath. And I cut the truck off and I went out there, and the fuel pump relay had literally caught fire. It was just burned burning everything up. And so of course I put out the fire. You'll get to where you're really calm about putting out a fire if you work on cars a lot, because you set one on fire every now and then, even if you don't need to. You just got to keep your head. I had one guy, one caught on fire, he'd jump around and go, ooh, ooh, ooh. Well, that doesn't do anything to get the fire put out, you know what I'm saying? And we used to see that every so often. So I fixed the relays, got the pigtail like I was talking about on the other one, put those relays back in there, made all that look good again. And then I said, there's a reason why the wire under the dash burned out, and I made that leak in the chain stronger, and then the relays caught fire, which is in the same circuit. See what I'm saying? So then I got to measuring, and this Ranger had 2 gas tanks on it, which was really strange, but it had 2 fuel tanks on it. It must be special ordered that way. The tank in the back was pulling 8 amps. The one in the front, which is the one he was trying to use on that front tank, was pulling 40 amps. That motor was partially shorted, and yeah, it was pumping fuel. Just like this motor right here, but these little windings right here were burned and shorted to the point of where it almost had no resistance at all. And so rather than blowing a fuse, the way that thing had a fusible link, which is a piece of wire that's one size smaller that's made to burn into it, it's got a heavy surge, it wasn't enough of a short to blow a fuse, that fusible link, but it was enough of a short to set things on fire and melt connectors and burn stuff up along the way. You see where I'm going with that? That was an unusual situation. He didn't want to pay for a fuel pump, so he was just stuck with using his back tank. But anyway, why was my alternator, though, when I was checking the charging system, reading only 12.5 volts? Because of the load, yeah. When you turn the load knob on our machine, your height pulls the voltage down and the amp goes up on the alternator. This son of a gun here, when you pull the voltage down, the voltage regulator picks up on that. It says, I need to give it more alternator fuel to bring the amps up. And you'll watch it on your machine. You bring the volts down, the amps go up. Because that voltage regulator system, if it's PCM controlled or if it's in the alternator, it's going to respond to lower voltage by increasing the amps. And it was really, that alternator, his other alternator was burned up. It wasn't strong enough to do anything. The new alternator put on there was good and strong. It was all muscled up. And it started punching stuff out. I mean, it was burning things up, cooking wires and melting connectors and everything else. That was a mess. But that was one of these electrical things that if you're not paying attention, this is the other thing. When you got a situation like that, the smart thing to do is not fix what you first find and then feel like it's all right, slam the hood and pull it outside. You better run that thing for a while and make sure it's okay, because if you don't, if it burns the truck all the way to the ground, they come back and say, hey, y'all were supposed to have fixed it, what's up with that? See, that would have happened if I would have let that one go without finishing my diagnostics, That burned. I mean, let's make sure nothing else happens now that I'm doing this, and so on and so forth. Then I use my inductive pickup. My old charging system tester hooked it up to the battery, clamped it around the wire going to the fuel pump, and so it was, pumping out all the amps. Anyway, somebody's talking about the relay, right? You okay with the relay? Everybody got that? You understand that? If you know coil, common, normal, open, normally closed, you can wire up anything. Oh, let me finish the other story I started telling you. I wired up the switch. The headlights on that Explorer. I fixed that, and they took it and they were happy with it, and they never gave me any more trouble. And to them, this was mounted in there behind that panel. When they turned on the headlights, they might have heard a little click when the relay clicked, but the relay was carrying the load. You see, the same circuit protectors were in place and everything. There was nothing wrong with that repair. And I got called on the telephone after I came to work here, 5 years later, 6 years later, it was like 2001. And this guy says, I'm actually working with Ford Motor Company up here, and I saw that where you fixed a vehicle that had this problem with burning up headlight switch. And he said, we've got a bunch of cars in Europe that are doing that. And I noticed the one that you fixed, you wrote on the warranty repair order that you had installed a relay to carry the load of the lights. I said, yeah, I did that. And he goes, well, how did you do that? Because I need to come up with a field fix for the ones in Europe that are burning up headlight switches. And I said, okay. And I said, give me an email address. And so he gave me an email address, and I got this wiring schematic, and I actually built a wiring schematic. It looked just like it was drawn by Ford. I was using paint, moving stuff around, all that hardwiring. And I fired that off to him, and that was his field fix that he published in a technical service bulletin to take care of the ones in Europe over there. My question was, this guy's an engineer that's working for Ford. Why couldn't he figure this out without knowing what I did? Of course, proof's in the pudding, And if I fixed one and it never gave the trouble again, that's what he was after. You see what I'm saying? And so, but anyway, since I'm underwater here with my thing, let me finish up on that.